So in the beginning of 3.1, there are two different types of questions when you get your quadratics at the beginning. One is if it's in quadratic form, where there's an x squared and there's an x. The other is if it's in standard form. Ax minus h squared plus. Okay. So two different formats, right? This was called quadratic. And this is called standard. So if it's, I'm going to go to the right first. If it's already in standard form, then our vertex comes out as HK. We change the sign on what follows the X. And then we keep the sign on what's outside by itself. We know the direction of the parabola. If it's a positive A, it opens upward. If it's a negative A, it opens downward. We find Y-intercepts by plugging 0 in for X and then finding the corresponding Y. We find X-intercepts by plugging in for Y, which is your f of X, and then using that even root property to square root both sides, putting the plus and minus. And then we graph. And we graph, axis symmetry. Axis symmetry is X equals H, which you can get as soon as you get the vertex. And then for these, we graph. If we graph the vertex and the intercepts and it's enough information to get the vertex and 1 point on either side of the equal sign, then we're good. If it's not, then we plot additional points. We plug in a point to the right of the vertex and a point to the left of the vertex. Now, if it's in quadratic form, we have two options. One is keep it in quadratic form. Get the vertex by doing negative b over 2a, and that gives me the h, or the x coordinate of my vertex. And then plug that back in and solve for the y. And that gives you your vertex, which is your hk.
Plug back into the original equation.
Plug back into the original equation. And then we have our vertex, which means we also have our axis of symmetry. Once we get our vertex, again, it's x equals h. Again, it's a line. Then we can find our y-intercept by doing 0c. We don't have to do much work there. We plug the 0 in for x and it eliminates, and I just get c. The x-intercepts, we plug 0 in for y again. Sometimes we can factor, or we can use the quadratic. So this is all option 1, if it's in quadratic. The other option is what we did yesterday and what we're going to start with today. If you want to wait, Audrey, I'm going to add to it, which is the complete the square. Correct. So we're going to take our ax squared plus bx. We're going to group it together. We bump the c to the outside. We take out the a if we need to, which we're going to do that today. We didn't have to do that yesterday. You won't have to do that on your quiz, but I'm going to show you how to do that because you will have to do it in the future. You're going to find this missing piece by doing b over 2 squared. And then you plug it in there. You're going to add it there. And you're going to subtract it from the outside. Then you factor. Square root first. Square root last. Sign from middle. Put it in parentheses, square it. Your c is still going to be on the outside, but it's going to be like c plus or minus your b over 2 squared. So let me actually not say c. This becomes k there. And then you're in standard form, so you go to where we did on the right. Find the vertex, which is HK. If the A is positive, it opens up. If it's negative, it points down. Find the Y-intercepts, find the X-intercepts, and the axis of symmetry. So that part from the complete the square up through the standard is what your quiz video is going to cover. Now I'm done, sort of. I don't know if you can read that, though.
Yeah, but I have a question.
Yeah.
So do you always subtract the C from the outside if it's, like, even if it's positive?
So what we're going to find is that we will always be adding inside the parentheses. Do you want to get on your phone or you want it on your iPad?
Or on my phone. It doesn't matter.
Do you know what your phone's called?
It says I've used my phone. Or I've used my phone.
There it is. It will always be an adding inside the parentheses, and it is usually a subtracting outside the parentheses, except if we've taken out something on the front that's negative. So we're going to see an example of that today.
Can I airdrop that?
No? Notice the middle term's not even. So this makes it a little bit harder, but the process is exactly the same. The good news is quiz-wise, your middle term will be even. The bad news is moving forward, they may not be. So you have to learn how to do it both ways, okay? So first set of instructions, put the equation in a standard form. This equation is clearly in quadratic. I'm going to change it into standard form by completing the square. Step 1, group the first two terms together. Bump the -4 to the outside, so the sign goes with it. Step 2, I have to figure out what fills, step 2 should be checked to make sure nothing's in front of the x squared that I have to take out. It's not, we're about to get there, we haven't yet, it's not. Now I take that b, I'm going to ignore the sign because I square it, which makes it positive all the time. I'm going to divide it by 2 and square it. So this is where it gets a little bit harder because 5 is not even, so this is no longer a whole number. 5 divided by 2 can't get simplified. It would stay as 5 divided by 2. And then I'd square it, and it becomes 25 over 4. So I add that inside the parentheses. And some people actually prefer to write it as 5 over 2 squared because that helps you when you go to square root it. That's totally fine. But when you subtract it over here, it has to be 25 over 4. So whatever I add inside the parentheses, I'm going to subtract from outside the parentheses. And now I have to do -4 minus 25 over 4. -4 becomes -16 over 4 minus 25 over 4, which is -41 over 4. So I'm going to rewrite my equation. Now I factor. So I'm going to square root the first term, square root that last term, which is the same as what we did before we squared it here, that 5 halves. Bring down the sign from the middle. Put it in the parentheses and square it. Don't forget the square. That's what makes it quadratic. Minus 41/4. With me so far? Yeah? So same process. Yes, it's yucky because it's a fraction, but same process. That's standard form. So I think that's like worth 25 points of your quiz. Just getting it to that point. Now we've got to find all the information from it. So the vertex, opposite of what follows the x, but keep the sign on what follows the parentheses. That's my HK. Axis of symmetry. X equals 5 over 2. And then I go Y-intercept, X-intercept. Remember, Y-intercept is so much easier to do from my initial equation. This would be 0, this would be 0, and it's just 0, -4. Make sure you put it in coordinate point form. You don't want to lose points on stuff like that. So you don't want to lose points on the not having x equals on the axis and the 0 not being there for the y-intercept. So it says smaller one and larger one. So when we find them, I'll show you what you do. Okay, then X-intercept. We're going to plug 0 in for Y. So you can do it up here. If it's factorable, it's definitely easier. But there's no factors of -4 that sum to -5. And it won't be factorable on your quiz. So the other way to solve it is to use your standard form. 0 equals x minus 5 halves squared minus 41 fourths. Add the 41 fourths. Square root both sides, putting a plus and minus in front of the 41 fourths. Nate, great question. It's what's going to happen in a minute, and we'll go over it. I'd get square root of 41 over 2, because it's the square root of 41 over the square root of 4, equals x minus 5 halves. I'm going to add the 5 halves. And I get 5 plus and minus square root 41 over 2. So I have 2 X-intercepts, which you almost always do unless it's just 0, 0. You either have 2 or you have none. Sometimes you have 0, 0. That's the only time you have 1. So when if I were to type this in on WebAssign, it wants the smaller one first. So the minus goes first. So 5 minus square root 41 over 2, comma 0. And then the bigger one, 5 plus square root 41 over 2, comma 0.
And you can do the quadratic for that.
You absolutely can do the quadratic using the initial question. Yep, absolutely. Honestly, extra time, I would do both and check it. Yep. All right, so now I've got to graph these. It didn't say to, but I'm going to show you how to because you're going to have to graph it on your quiz. So I'm going to graph my vertex, which is 5 halves, or 2 1/2, and negative 41 over 4, which is negative 10 1/4. So I'm going to go to the right, 1, 2, 3. I'm going to go right 2 1/2, and then I'm going to go down 2. I'm going to go by 2. So negative 2, negative 4, negative 6, negative 8, negative 10. Some of the numbers on your tests are big. On your quiz are big. So feel free to adjust your axis so it makes sense. My Y-intercept is at 0, negative 4. So it's here. And then my X-intercept is 5 minus square root 41 divided by 2 and 5 plus square root 41 divided by 2. You can use a calculator to figure that out and approximate it. Do it. It's going to save you time. If not, you have to approximate square root 41, which is a little bit bigger than square root 36, that kind of thing. But I'm going to just use the calculator to find that point. When I list it, I need to keep it exact the way that it is. But when I go to graph it, that is negative 1.4, 5 plus square root 41 divided by 2 is positive, 11.4, not negative, 11.4, and then 5.7. Wait, did I do that right? Hang on. 5 minus square root 41 divided by 2. I just rewrote the wrong answer. 5 minus square root 41. This is negative 0.7. 5 plus square root 41 divided by 2. 5.7. Yeah, okay. So negative 0.7 is here. 3, 4, 5. 5, 7 is here. And then I draw my graph. Axis of symmetry should pass right through the x coordinate of your vertex because it's x equals 2 1/2 or 5 halves.
How did you graph the X-intercept?
I just, for this, because those are not perfect squares and they're not going to be on your quiz, I literally use the calculator to figure out what those would be.
So it doesn't have to be perfect. But not
When you give the answer, it needs to be kept exact. So you would give it as 5 minus 41 over 2. Don't use the calculator there. But when you go to graph it, you're going to have to approximate it. So you can use
it's
it.
not like perfect. We're not going to get it.
Correct. As long as you have 5 minus 41 over 2, that is right, you're good. So again, the process we just did is exactly the same as what you're going to do on your quiz. The good news is that there's not the fraction. But you are going to see that again, so obviously we needed to go over it. All right, this one, I think there's one more after this with the negative, right? Yeah, okay. This one has y equals 2x squared minus 3x plus 1. So first beginning step, I'm going to group together my 2x squared, my 3x, and I'm going to bump the positive 1 to the outside. Now there's an a. There's something other than the 1 there, which means I have to factor it out. When I take that 2 out, I am dividing both the x squared and the x term by that 2. So I end up with y equals 2 times x squared minus 3 halves x plus 1 still on the outside. So what you take out from the parentheses has to get taken off of both terms. Now even more fun. B is a fraction. 3 divided by 2 squared becomes 3 halves times 1 half squared, 3/4 squared, which is 9/16. And this is, again, some people keep it as 3/4 squared here to remind you what's going to happen after you factor it. Now normally, and this is super important, normally we add it inside the parentheses and subtract it from outside the parentheses. But before we can subtract it over here, we have to multiply by what was on the front. So up to this point, we never multiplied by something that was on the front because there was nothing on the front. Now there is. So it becomes negative 9/8. So I get 1 minus 9/8, which is 8/8 minus 9/8, which is negative 1/8. So I get y equals 2 square root the first term, square root the last term, which was what's inside the parentheses here, 3/4. Take the sign from the middle, put it in parentheses and square it, minus 1/8. There's your standard form. Yep.
I remember we did something this for a while ago. I would like start by dividing like by 2. Like I did it like in a different way. I don't remember. Is there,
So
like,
the problem is that you were dividing when it was set equal to 0.
Oh.
And it's no longer set equal to 0. So you can divide y by 2 at the beginning. If you divide everything by 2,
Yeah.
right, then y is over 2. Then you just have to multiply it back at the end. So it doesn't help tremendously because it's not equal to 0. But you can still do that.
Okay.
So now I get, right, my vertex. I'm not going to go all the way through this. Oh, sorry.
Real quick, so the blue stuff is once you get the, okay.
That third term.
By the 2 times the negative 9/16, right?
Correct. So whatever you take out on the front, you have to multiply by what you're normally subtracting from the outside before you subtract it.
But you have to add the 1 and subtract the 9/8 first, then multiply by 2?
No, we multiplied by 2 first. Oops. We multiplied the 19 by 6 first, and I got negative 9/8. So then I did 1 minus 9/8.
Oh, okay.
Why did you do negative?
Because whatever we do inside the parentheses, remember we add inside the parentheses, we have to do the opposite outside.
Mm-hmm.
So do we know where to go from here? My vertex would be 3/4 and negative 1/8. My axis symmetry is x equals 3/4. To find my y-intercept, I'd go back up here. My y-intercept would be 0, 1. My x-intercept, this time I can actually factor. And I get 1/2 and 1. And then you graph it using that information. So 3/4, negative 1/8 is like here. 1/2 and 1 is here. And 0, 1 is there. So this is a teeny tiny problem, but it's there.
I have a question.
Yeah.
I'm gonna try to make it make sense.
Oh, good. This should be fun, Juliana.
In the previous slide, the negative 5x was in the middle, and that's the one that you have to divide by 2 and then square to find out what you have to add and all that.
Yep.
So for that one, the 5 isn't divisible by 2, so then we just squared 5 over 2.
Yep.
But in this slide, we actually multiplied it by 1/2. Why is that different?
Because the 3 over 2 is what we have to divide by 2 this time. So it's actually 3 over 2 divided by 2.
Oh, okay.
Does that make sense?
Yes.
Okay.
Thank you.
Yes.
So we just take the 2.
The A is what makes it more narrow. So it would impact anything that's plugged in, right? If we plugged points back in, the 2 would be more narrow. But because we're finding all the other information, it naturally takes care of that narrow. Yeah.
And for
Yeah. Okay, last one that we're going to do, and then we're going to move into that next part. So put the equation to standard form, find the vertex, the y-intercepts, x-intercept, and axis. This time, I'm going to start the same way, but I have a negative on the front of my x. That negative has to come out. When I take it out of the x squared, I also change the sign on the 3x because you're dividing both of those by -1. Yep.
So in order for these to work, it has to be a negative.
Positive 1x squared. A negative where?
Like on the 3x, like on the second term.
It doesn't have to be negative there. It just can't be anything other than +1 there.
No, like for the 3x, how did you complete the square if it was like a positive?
It doesn't matter. It just changes when we factor. The middle term would be positive then.
And then
Yeah.
you would add to the other side?
Nope, because you're still squaring. Whatever it is, you're squaring, so you add it inside the parentheses. And normally we subtract it from outside the parentheses, but now the negative's going to change that. Is that what you mean?
Yeah.
Yeah. Okay, so let's do the next step, which is take the 3. It doesn't matter that it's negative because we're squaring it. 3 divided by 2, square it, and I get 9/4. Add the 9/4 in here. If you want to write that that's 3/2 squared, so you remember after you square root. And normally we subtract the 9/4 here. But because there's a -1 on the front, that negative has to get multiplied by that fraction first, which now means we are adding 9/4. So if I take out a negative, instead of subtracting outside the parentheses, I now have to add. So I'd get y equals -x minus 3/2 squared. -4 plus 9/4 is -16/4 plus 9/4, -7/4. And here's my standard form. So this parabola changes because it's pointing downward. The vertex is positive 3 over 2 and -7/4. The axis of symmetry is x equals 3/2. My y-intercept is 0, -4. And I know that from plugging in zeros to my initial question. Now let's look at our x-intercepts. That first one is not factorable. Yeah.
Why is the negative still on the front if you multiplied it?
The negative is still on the front because all we did was multiply it to make sure that we change what we add, but the negative is still there. We just took it out. It's still on the front. It's like factoring out a greatest common factor. Notice that 2 on the last one, the 2 stays there. So the negative still stays there. Yeah.
Miss Crucializer, when we multiply the plus 9/4, is it always the opposite? Like if it's because it's plus 9/4 and then we multiply it by -9/4, is it the opposite of what it is in the?
So if there's we do the opposite of what's here, usually to this part. But because the negative is here, it's going to change its sign.
Okay. Thank you.
You're welcome. Okay, so Yeah.
I'm still a little confused as to how you got the 3/2 in parentheses when you finally got the standard form. What's that? The product?
You square root 9/4.
Okay.
Okay, so now what happens when I go to solve this to find my x-intercepts? I get 0 equals negative x minus 3/2 squared minus 7/4. I need to solve this. So I'd add 7/4 equals negative x minus 3/2 squared. Then I'd have to divide both sides by -1, and I get negative 7/4 equals x minus 3/2 squared. Then I square root both sides, putting a plus and minus in the front, and then I get square root of negative 7/4. Can I do that? No. So there are no x-intercepts this time, which means my graph, which is to the right 1.5 and negative 1 3/4, and my y-intercept, which is negative 4, makes sense. It points down because it's negative, so it makes sense it's not crossing my x-axis. To find an additional point, I would literally just have to plug in another point. So there are going to be times when there's no x-intercepts. I'll tell you now, it's not going to happen on your quiz. Your quiz, you're going to get x-intercepts that are real numbers. Yeah.
So let's say you did it from the first equation and then did quadratic.
You would get the square root of a negative either way.
And then that's like whenever you get an I,
It's, yep, you can't graph it. Yep.
I remember my question.
Okay.
I don't know why that word is so hard. Are we gonna have to plug in points for our quiz?
If you don't have an intercept that you can graph, then you have to plug in points. So on your quiz, you should have intercepts.
And we're gonna have to graph too?
Yeah.
Okay, I don't know why I couldn't think of that. That took so long.
This is what your quiz question is going to look like. Screenshot your question, open a video recording app like Explain Everything, Educreations, or Doceri, and insert the question. Record yourself explaining how to do the problem while you complete it. Don't skip steps. Save the video to your camera roll, and then submit the file by clicking on, and this little icon is this little icon, that guy. Okay, I don't know why that didn't show up in the picture, but it should be the one that looks like a film strip. Then you're going to click Upload Media, then select the video file, and then choose the file in the photo library. So this assignment is designed to help you walk through this process before you actually do it for a quiz grade. Then it says, put the following equation into standard form by completing the square. Once it's in standard form, identify the vertex, the axis of symmetry, and the x and y intercepts. So here's our practice question. It says, f of x equals x squared minus 4x minus 6. So I am going to screenshot this question, just like you're going to do on your quiz.